Chapter 3 to 4. Increased Training Datasets, Final Part. In Chapter 3 to 3, I compared the performance of models A and B using 1 and 2 training datasets. Now, I evaluate models A and B alongside model C. As depicted in the figure, model C is trained with 3 datasets. This chapter concludes the investigations carried out in chapters 3 to 1, 3 to 2, and 3 to 3. Chapter 3 to 4. 3 research questions. This study investigates 3 main questions related to the increase in training sample quantity. First, does the confidence assessment of the Meta AI enhance the accuracy of the AI model? Second, does increasing training samples lead to more testing samples surpassing a 95% confidence threshold? Third, does increasing training samples enhance the prediction accuracy of the selected testing samples? Chapter 3 to 4. 3 research questions. Conclusions. Yes. The prediction accuracy for the selectively collected testing samples is consistently higher than that for all testing samples after the Meta AI selectively collects them. Yes, increasing the training sample quantity enhances the Meta AI ability to selectively collect testing samples. No. While increasing the training sample size contributes to the AI model's recognition of the selected samples, further accuracy enhancement requires additional factors. 3 to 4. Research question 1. Prediction accuracy with confidence assessment. 1-to-1 research question. Does the confidence assessment of the Meta AI enhance the accuracy of the AI model? Case A. Meta AI assesses confidence values for testing samples and selectively collects them for AI model prediction. Case B. The AI model predicts all testing samples without the confidence assessment. 1 to 2. Conclusion. Yes. After the confidence assessment for testing samples, the accuracy of selected samples consistently surpasses that of all samples. 1 to 3. Evidence 1 from experimental results. The prediction accuracy for selected testing samples is about 10% higher than for all testing samples. As seen the following tables for dataset 1 and 2a. The prediction accuracy for selected testing samples is about 10% higher than for all testing samples. Also, as seen in the following tables for datasets 1 and 2b, the prediction accuracy of selected test samples is approximately 10% higher than the accuracy of all test samples. 1 to 4. Evidence 2 from experimental results. The figure illustrates how each metacognition AI model categorized the same testing samples into confidence intervals. Models A, B, and C then made predictions based on these assigned ranges. As shown in this figure, all models consistently demonstrated higher prediction accuracy for samples surpassing the 95% confidence threshold, compared to predicting all testing samples. Chapter 3 to 4. Research question 2. Training sample quantity and selected sample quantity. 2-to-1 research question. Does increasing training samples lead to more testing samples surpassing a 95% confidence threshold? 2 to 2. Conclusion. Yes, but with diminishing returns. Although there's an initial increase, it doesn't persist with further training samples. From metacognition Model A as the baseline. There's no significant increase in the number of testing samples surpassing the 95% confidence threshold from Model B to Model C. 2 to 3. Evidence from experimental results. When training samples increased from Model A to Model B. As shown in this table, the number of testing samples with over 95% confidence increased across all testing datasets. However, when training samples increased from Model B to Model C, as seen in this table, the number of confidence testing samples decreased. Chapter 3 to 4. Research Question 3. Training sample quantity and prediction accuracy. 3 to 1. Research question. Does increasing training samples enhance the prediction accuracy of the selected testing samples? 3 to 2. Conclusion. No. Simply increasing training samples doesn't significantly enhance the AI model's accuracy for testing samples exceeding 95% confidence. 3 to 3. Evidence from experimental results. The table suggests that the prediction accuracy for the selected samples does not improve as the training sample quantity increases from Model A to Model B and from Model B to Model C. Chapter 3. AI Testing Epilogue. In this chapter, I've concluded the following. 1. Increasing training samples improves the meta-AI ability to select confident testing samples. 2. However, just expanding the dataset doesn't guarantee better prediction accuracy for the selected samples by the AI model. 3. To address this, I suggest a multidimensional AI recognition design. In this chapter, I examined object recognition using a single meta-AI and a single AI model, which represents as one-dimensional AI recognition design. However, in the next chapter, I explore the utilization of multiple meta-AI models and AI models, referred to as multidimensional AI recognition design. Thank you.